Good afternoon, everyone. Let's get started. So, my name is Ganesh Srinivasan. I'm a program manager in the Azure networking team, and I'm really excited to be here. And I have, I think we set a record in the number of speakers that we're going to have in this session. So, we're going to have 6 speakers come and go, and it's going to be like a whirlwind out here. So, stay tuned for a lot of exciting content from here. So, I thought it would be best for us to hear, rather than us talk about real-world usage scenarios, we thought it would be best for you to hear about how to use ExpressRo from real customers who've been using our product since the very early days. So I'm really excited to have Salim from Booz Allen Hamilton, Bobby from GE, and Leslie from Textron. And they're going to talk to us about how they've used ExpressRo and how ExpressRo has enabled them to migrate workloads to the cloud and how they could consume pretty much all these services from the cloud, and move from on-premises to the cloud. So we have a packed agenda. So I'll kick it off by giving you an overview of what ExpressRo is if you're new to this topic. We will follow that up with some learnings that we've had and things that could be, we've seen over and over again that you could work around and that you could solve. We'll talk about tricks that you could use in the routing plane to solve some of the problems that you've been facing and what our general best practices guidances are around handling routing. We will then have each of our customers come on stage and spend some time talking about what they've done and how they've consumed Azure and other Microsoft cloud services through ExpressRo. And we'll wrap it up with, we've sent some confusing messaging around ExpressRo in Office 365 and CRM Online. We will clarify the messaging that we have right now and explain what the next steps are for you to be able to be successful in connecting to those services. So let's get started. So how many of you have used ExpressRo in the past or are in the process of using ExpressRo? OK, not very many people, but it's always good then. So ExpressRo is one of our services that basically enables you to connect to the Microsoft Cloud. I'm saying Microsoft Cloud because it covers services not just limited to Azure. It covers services in Office 365 and CRM Online as well. It's a single service that can connect. It will extend a connection from your premises through a connectivity provider into the Microsoft network. And it offers certain good benefits in the sense that it's a private connection that extends your on-premises network into the Microsoft Cloud. We have a high availability SLA of 99.95. And we have a rich ecosystem of partners who can bring connections right from your doorstep into the Microsoft data center. So we work very closely with a large number of global telcos and exchanges around the world to extend connectivity into Microsoft. Now, since we talk about extending connectivity right from your premises into the Microsoft data center, there are 3 distinct modes in which you can have connectivity established. First thing is basically having a connection from a cloud exchange or a colocation facility all the way into the Microsoft data center. A good example of this would be Equinix. So if you're in one of those colocation facilities and you just want to extend your network into Microsoft, you can have a wire from your cage go into the cloud exchanges that are located in that facility and have a cross connection, a virtual cross connection established into the Microsoft network. So you will have a pipe that's established, a logical pipe that's established between your routing infrastructure and Microsoft. You control the routing session directly with us, and you manage connectivity yourselves. Now take it one step further. You're not in that colo facility, but you're in that same metro or you're a few 100 miles away from the peering location. You could work with an Ethernet provider or connectivity provider. A good example would be level 3. You could bring them and you could extend your connectivity into Microsoft through them. So they connect to us through the peering locations and extend your network into our network. And the third scenario is where you could essentially have your MPLS network directly paired with Microsoft. So you can have all your branch offices connecting to each other, and you can make the Microsoft Cloud look like just another branch office. And a good example would be AT&T. You can work with very many providers around the world. Each of them can fit into one of these connectivity models. Now, where do these connectivity providers connect to us? So we have points of presence, I think 27 points of presence all over the world. These are entry points into the Microsoft network. So you connect to us at any one point in any of these locations through the preferred connectivity provider. You can pretty much reach any other location in that geo, any Microsoft Azure, Office 365, or CRM Online location in that geo by default. And if you enabled premium add-on, you would be able to connect to pretty much any region, anywhere in the world. So as a good example would be, if you were to connect to us at Silicon Valley, if you had standard, you had access to all the Azure regions anywhere in the world. And if you had the premium SKU for ExpressRoute, you would be able to reach any destination within Microsoft. So you could reach a destination in Australia as easily as you could reach a destination that's right in US West. In addition to having these peering locations for our what we refer to as the public cloud, we have what is called as national clouds. These are isolated cloud environments serving very specific market segments. A good example would be the US government cloud. So we have a specific cloud deployment that's completely isolated from our public cloud, specifically for US government customers and defense contractors. So in fact, we'll have Leslie from Textron. His company does a lot of defense work, so they use the government cloud. And it's a good example of how customers use the government cloud. We also have a cloud in China that has ExpressRoute enabled. And you could connect to 2 of our regions from a provider in China. And the latest addition to the list of national clouds is the German cloud. We have 2 regions and 2 peering locations in Germany through which you could connect to the German cloud. We have a long list of partners, and this list of partners are global, and it keeps growing every day. So this is just a point-in-time thing, and this list gives you a list of all the providers we have in production today. So we talk about ExpressRoute. ExpressRoute is about a couple of years old. And over the last year, since Ignite last May in Chicago, I wanted to kind of show you a list of announcements that we've made over the course of the year. So the very first thing we did at Ignite last year, we announced the preview of ExpressRoute for Office 365 and CRM Online. And as of last October, we made it generally available for a lot of customers. We changed the billing model completely. We reduced prices for connectivity by up to 97% for some SKUs to make it a lot more affordable, and it's a COGS neutral SKU for us. Our intent is to enable you to connect to Microsoft and consume all our services, so we've slashed our prices significantly. We've spent a lot of time introducing these government clouds, isolating and building replicas of our public cloud for all these geopolitical regions and these national clouds, and we've extended it to new geos like Canada and UK. And we've added a whole new set of partners, including educational networks like JISC and Giant and so on. In addition, we've introduced a lot of features into the platform. One thing that we did last year was announce Azure Resource Manager as a new programming environment for Azure. And unfortunately, our classic way of doing things and the Resource Manager way of doing things were parallel universes. We were one of the few services that enabled coexistence between the 2 universes and enable connectivity between the 2 worlds. You could migrate your ExpressRoute circuit from the classic world to the Resource Manager world with 0 downtime, and essentially take advantage of all the cool features in Resource Manager. Since Resource Manager was a new environment, we had to do a lot of things to get to feature parity with what we had in the classic environment. And of course, we did add a lot of automation in terms of how we do routing. So a good example would be support for BGP communities that we added for public peering and Microsoft peering. And we also did some work in terms of automating prefix validations. When we peer our networks with yours, we want to know that you're trusted and you're connecting to a trusted private network on the Microsoft side. So we did a lot of work in validating who you are before we extended your network into the Microsoft cloud. Now, these were things that we announced over the course of last year that have been in production for a while. So let's talk about what's new. If you looked at Yusuf's keynote on Monday, there was certain themes in which we delivered features on. The very first thing is performance. So you would have seen that we announced accelerated networking for the cloud platform. And we announced other cool features like virtual network peering that enables you to build hub and spoke architectures. When you go into those kinds of scenarios, if you're building a hub network in Azure that you want to extend back into your premises, you want to have a higher bandwidth VPN gateway or an ExpressRoute gateway that connects you to your on-premises. So with this release, you will be able to have an ultra-performance gateway for your ExpressRoute virtual networks, and they go up to 10 gigabits per second. A single virtual network can sustain traffic of up to 10 gigabits per second right now. We've also done a lot of work to improve the reliability of the service. Not that it was not reliable, But right now, we've increased our SLA from 99.9% availability to 99.95% availability. That extra half and nines was a lot of work under the covers to make sure that your connection is disruption free. A lot of people come to us and ask us, I've turned on ExpressRo. I am stuck somewhere in my connectivity process. What can you do to help me? So we've started a long journey in terms of enabling monitoring, telemetry, and alerting. The first installment of that is out in production. So this will enable you to debug connectivity issues. I'll get to that in a little bit. And finally, since we've increased our reliability to 99.95, the architecture of our basic gateway SKUs did not really lend itself well to be upgraded to the higher SKU. So those who have the existing basic SKUs can continue to use it at 99.9% SLA. The newer SKUs will be automatically getting the higher SLAs, and we will not be supporting no new basic gateways from this point on is our message to you. So let's look at, I talked about troubleshooting and telemetry and insight. So what does it mean? When someone turns on ExpressRo, it's a front-loaded service where you have to plan a lot and then start turning on the service. The first thing you want to know is, have I plugged my wires correctly, and have I established the connection at layer 2 properly? The way to do that is to essentially look at the ARP tables for your service. So we've now integrated it with the portal. So by just clicking the portal, you'll get the ARP tables for your primary and secondary links for your ExpressRo circuits. The next thing you want to know is, do I have layer 3 connectivity between my network and Microsoft? And the way to do that is to look at the route summary. Now, what we do is you have per peering, you connect to us at the edge of our networks, and then we extend the edge into your virtual network. So you have multiple BGP sessions, one coming from your network into us, and one from each virtual network into the edge location. So if you wanted to validate routing between your on-premises all the way up to the virtual network, you can look at the route summary and look at all the entries in there and figure out whether they're up or down. If you're unable to reach certain prefixes, all you need to do is look at the route tables and see whether the prefixes are advertised either by us into your network or by you into our network. So if you're unable to connect to a network, you can look at the route table at any point in time and figure out whether you have a connectivity issue or not. And last but not least, once you've gotten routing set up, you want to know whether data transfer happens through your network. And you can look at bytes in and bytes out at 5-minute intervals as instantaneous values right now. And this will help you troubleshoot most of the basic scenarios that we've encountered in production. We looked at the support cases and so on. So these are what we have for you right now. And I'm going to introduce Charlie Wen from my team. And he's going to be talking about how you can manage routing and what things you can do to optimize routing within your network. Thank you.
Thanks, Ganesh. Thanks, Ganesh. So as Ganesh mentioned, we launched ExpressRo more than 2 years ago. Many customers and many of you started with a very simple configuration, simple circuit, VNet, and you started with simple dev test scenarios. Now, in the past few years, we added more locations, as Ganesh pointed out. We added more new features. We are seeing customers are having more complex deployment. So we learned a lot from these customers, and we want to, in the next few minutes, I want to share with you the lessons we've learned and the best practice we want to recommend. So I will start with some basics. If you already know this, just bear with me for a minute. So as Ganesh mentioned, ExpressRo circuit supports multiple cloud services, but that's on the Microsoft side. The question is, how do you actually map these services to your private network, right? So for security and for compliance reasons, our suggestion is to map these services to 2 routing domains. Your Azure VNet is essentially the extension of your core network. You run private IP address, the traffic is bidirectional, so it's a routing domain by itself. Office 365 Azure public services are multi-tenant services. Your deployment, your services are hosted in the same infrastructure as other customers. So our recommendation is when you send traffic to these services, you have a security zone, have a DMZ, have a firewall to examine these packets. So that's our suggestion. Next, we actually received this question a lot, particularly in earlier days. What's your IP address requirement? What's your ASN number requirement? So let me clarify this. For Azure private PAing, you can send us either private IP address or public IP address. For Microsoft peering, you must send us public IP address. For Azure public peering, we didn't have a strict requirement in the past. You can send us either private IP address or public IP address. However, moving forward, we strongly recommend you to send us public IP address on Azure public peering. As for ASN number, we also allow you to use the private ASN or public ASN. We allow you to use a 2-byte or 4-byte ASN. If you advertise a route to us, we strongly recommend you to use a public ASN. The reason being, when you advertise a route to us, and if you use a public ASN, we can automatically verify your IP. Right? If you already have a service up and running, you want to change your private IP, prefix you advertise to us, we automatically verify it for you, and your service can be kept up and running. So that's the recommendation we have for you. So these are the basics. So next, let's talk about some common deployment scenarios. Now, as Ganesh and I talked about, we've seen more customers are having more than one ExpressRo circuit. Here's a typical example. A customer has, you have 2 offices, one in LA, one in New York. The offices are plugged into your IP VPN network or plugged into your service provider's IP VPN network. You have 2 ExpressRo circuits, you have 2 VNets, right? So you actually you link these VNets to your ExpressRo circuits. So you have this fully meshed network. So from redundancy point of view, that's good because there's no single point of failure in that network. But it's actually, if you look from a routing perspective, it's not optimal. The reason being, if you look at the US West VNet, it's receiving this route, a router from your office on 2 links. Without any configuration, we'll do load balancing on these 2 links. Okay, so when your VNet, your US VNet sends the traffic to your LA office, right, some traffic will be sent to the LA circuit, some traffic will be sent to the New York circuit. That's not ideal. The solution actually is very simple. You can use there's a technique called AS-path prepending. So AS-path basically is the attribute of a BGP route. So when a BGP sees a route from multiple sources, you will look at the AS-path with each source. It will pick the shortest, the source that with the shortest AS-path. So back to this example, the US West VNet will see the 10.1, that's your LA office, from both your LA circuit and your New York circuit. But the route from your LA circuit will have a shorter circuit, a shorter AS path. And for that reason, when you send the packet, we actually will send the traffic to the LA circuit. So that you achieve the optimal routing. Okay? So that's good. How about redundancy? Right? Redundancy is really your ultimate goal. So if LA circuit goes down, right, and the route you learned, the VNet learned from the LA circuit will be removed from the routing table. And as a result, when the VNet sends traffic to your LA office, the traffic will send to your New York circuit. So you have optimal routing, and you have you also have redundancy. So that's actually how you can influence routing from traffic from Microsoft to your private network. So how do you influence routing from your own network to Microsoft? Okay. So in the same example, you basically receive on both of your LA router and a New York router, you receive the same route from your VNet, right? But let's continue to look at your US West VNet. You know that the VNet is on the West Coast, right? So you can set a higher local preference, which is another technique, BGP attribute. You can set a higher local preference for the route on the LA circuit. Okay, so now your network will know that when I send traffic to Microsoft, any traffic sent to the US West VNet will take the LA circuit. Okay, so then you also have a redundancy because if the LA circuit goes down, right, the VNet also learns this route from the New York circuit, so the traffic will route to the New York circuit and then send to your US West VNet. So you have a full redundancy, and also have your optimal routing when you have multiple paths between your VNet and your office. So that's multi-path, and we are seeing more customers are using this, so we want to give you some idea how you can influence routing. Forced tunneling is another very common configuration. And the intention is very simple, right? You want to secure your VM connection to the internet. Right? You want to make sure when your VM opens a connection to the internet, the traffic doesn't go from Azure to internet directly. You want to make sure the traffic goes to your private network first. Maybe you have for compliance reason, maybe you have a firewall in your on-prem. So for these reasons, you want to enable forced tunneling. The implementation actually is very simple. The implementation is very simple. You advertise a default route to us, okay? So when you advertise the default route to us, when a VM open connection, and we'll send the traffic back to you. Now the question is, what if actually ExpressRo goes down? What if actually the BGP actually is broken, right? You want to continue to have this policy. You want to prevent your VM talking to your internet. How do you enforce that? The solution is by using network security group. Network security group essentially is a set of echoes. So for this purpose, you only need 2 echoes. You have one echo to deny traffic to the internet. And then you have a higher priority echo to allow traffic for the virtual network. So here's how it works. So when the BGP is up, when the ExpressRo circuit is up, you receive a default route from your private network, right? So the default route will be part of your virtual network. So when a VM opens a connection to the internet, it will hit the traffic, will hit the first echo. The first echo is allowed, so the traffic will go back to your on-prem. Now when ExpressRo circuit goes down, when BGP goes down, your virtual network will no longer receive this default route, right? So when a VM opens a connection, the connection will actually hit the second echo. The second echo has a deny rule. And so for that reason, the VM will no longer be able to connect to the internet, right? So that's a nice trick you can play. So we call that forced tunneling failsafe. Okay, so in the context of forced tunneling, some customers ask us how routing works between a VNet and Azure public services. So let's say a VM opens, your Azure VM opens a connection to a web service, right? How does the traffic flow? Well, when a VM opens a connection to Azure Web Service, the traffic will go back to your on-prem because you have a forced tunneling, right? So when your on-prem firewall may log the connection, examine the packets, if everything's okay, the return traffic will come back. You can route the traffic back to on-prem. The return traffic will traverse on Azure public API. So that's good. Now, what if actually you want to make some exemptions? So for some reason, for performance reason, for example, if your on-prem is actually far from Azure, right? If we're doing this hairpinning, you have a longer latency. So what if we want to make some exemption? So what you can do is by using UDR. You can use UDR, essentially a static route, to override the BGP route. So with UDR, you can configure this UDR on Azure VM, and the VM can talk to the Azure Web Services directly. So when you apply UDR, also remember to apply network security group because essentially the VM is no longer subject to forced tunneling. You want to make sure you can use echo to close your endpoints for your VM. Okay, so the next topic is one of my favorites. It's asymmetric routing. If you actually have deployed a complex environment or Office 365, you may actually have this problem. So let's look at a simple example for this enterprise customer. So this is a customer network. You have users, you have servers, you have internet gateway, you have a firewall, right? And you have 2 types of connections. When a user opens a connection to the internet, that's what we call outbound connection. When a user from the internet connects to a server in your on-prem, that's actually what we call inbound connection. So the firewall is a stateful device. The reason being, it examines packets in both directions. For TCP connection, we look at the SYN and SYN-ACK. If the firewall doesn't see these packets, it basically will drop any subsequent packets of this connection. Now, this is very technical, but from a user experience point of view, if you connect to try to connect to internet, if a firewall doesn't see these packets in both directions, the firewall will drop the packets, and you will not be able to connect to the destination. So that's a user experience. That's actually bad user experience. So with ExpressRo, you add ExpressRo between your private network to Microsoft. And essentially, you have an additional connection to Microsoft, right? Some services hosted on Microsoft, you have additional connection to that service. So that's actually where asymmetrical routing can happen. So before we talk about specific examples, here are a few things you should know. First, routing is based on most specific prefix, or as known as longest prefix matching. Second, ExpressRo is preferred to internet, meaning that if we receive a prefix from you on both internet and ExpressRo, the return traffic we send to you will actually be sent on ExpressRo, okay? And also, last but not least, when we advertise routes to you, the routes we advertise to you on ExpressRo will be more specific than the routes we advertise to the internet, okay? So these are the things you need to remember. So with that in mind, let's look at some typical example. So let's say the user opens a connection to the internet, to Microsoft in this case, right? The destination basically is a Microsoft IP, so the traffic, the initial traffic will go over ExpressRo. Now let's say in this case, the admin for this customer forget to advertise the public IP of this user on ExpressRo. Okay, because the IP is not available on ExpressRo, the return traffic will go back to the internet. And the return traffic will be dropped by the firewall on the internet side. Okay, so that's actually a typical asymmetrical routing problem. So let's look at another example. This is our inbound connection asymmetrical routing problem. So let's say you have a server. Let's say you have an SMTP server in your on-prem. And let's say Microsoft initiates a connection to you. Before that, let's say you are not advertising the public IP of this server to Microsoft on ExpressRo. Okay? As a result, when we open a connection to you, the connection will go over the internet. Okay? Now, when the server sends a return packet to Microsoft, remember the destination is a Microsoft IP. Right? You learn the more specific Microsoft prefix on ExpressRo. And as a result, this return traffic will go over ExpressRo. So again, you have an asymmetrical routing problem. The solution is simple. Okay? One of the solutions is you can use a source address-based net. So our recommendation is on each of these, for your outbound connections, you have a unique net IP on each path. Okay, for that, if you have that, when we receive your connection, we know exactly where to return the traffic to you, whether it's on ExpressRo or on internet. Okay, so that's for outbound connections. For inbound connection, you can do the same. When we send the traffic to you, right, when you receive the packet, inbound connection, when you receive the packet, you change the source IP address, which is the Microsoft IP address, to a unique IP address in your network before you pass the packet to your server, SMTP server, for example. And then when the server sends a return packet, right, and the packet will send, rather than send to Microsoft, it will send to the device that does the net. So then you can keep the symmetrical routing. So that's asymmetrical routing. So one thing I want to talk about is, Ganesh mentioned that a BGP community is a relatively new feature. BGP is essentially just a tag. It's just a string you configure on your router. We support two types of BGP communities. For Azure public IPs, we tag the IPs by region. So you have IPs from US East, you have IPs from US West. And for Office, the IP is tagged by service. And you have a Skype, you have a SharePoint. So BGP community serves three purposes. You can manage BGP, you can filter routes by BGP communities so you can keep your routing table small. You can also control routing. Say you only want to send the Skype business traffic on ExpressRo. So you can filter out Exchange and the SharePoint. And by that, you also make the best use of ExpressRo circuit. Sharing ExpressRo circuit is a common configuration. We have two techniques. One is the good old link operation. You can link VNets to the ExpressRo circuit. The new technique is a new feature, is enabled by a new feature, VNet peering. You can, let's say you have a set of VNets, and you can link one VNet to the circuit and peer that VNet to other VNets, and enable transit routing so that other VNets can talk to your on-prem through this linked VNet. So it enables many scenarios, like a DMZ scenario. I'm going to leave this to our other presentations. This is probably my last slide. And this ExpressRo and the VPN is we call it coexistence. It's also a very common configuration. It supports two scenarios, hub and a spoke, and also high availability. In the past, we had some limitation. We added a few new features to address this limitation. One is support of a BGP on side-to-side. With that, you can enable forced tunneling on both ExpressRo and the VPN. And also, we added a point-to-side VPN support on this setup. So with that, I will hand off to Ganesh to introduce our guest speakers.
Thank you, Charlie. So what Charlie gave you an overview of right now. Thank you, Charlie. So what Charlie gave you an overview of was common pitfalls that we've seen from our customers. Now, I'd like to bring on stage a couple of our customers who've managed to successfully work through some of the challenges that we've talked about, and they've realized real-world scenarios from this. So I'd like to first introduce Mr. Salim Nert from Booz Allen Hamilton, and he's going to be talking to you all about how they use ExpressRo to essentially extend their networks into the Microsoft Cloud.
Thank you. Thank you. Now that I was watching the presentation, I think they built the entire slide deck from our issues and challenges and problems we went through, because we did experience just about every slide was out there. Thank you. So I work for Booz Allen Hamilton. I'm a principal architect. I'm in charge of Booz Allen's IS enterprise architecture, the architecture team. So we come up with new technologies, innovations to help the company and also help our clients as well. Booz Allen has been in the consulting, technology, and engineering services business around the globe for a long time. We just celebrated our 100 years last year. So we're strong. We continue to grow. We have about 22,000 plus employees, and we hire people every day and expand our services. And last year, we made about $5.4 billion in revenue. But we are here to talk about why we picked Azure and why implement these services, right? Before I go in there, I wanted to talk about these, the demands and the unspoken, I guess, the challenges we have in IT, right? The first thing, like everyone, we are required to implement new services and offer new innovations, but we have to do it fast, right? And we have to do it yesterday. And the other thing is the experience, right? We can, no matter how fast we implement things, but if the clients or our users do not have a great experience, it's meaningless. So how do we create that experience? We ask ourselves all the time, right? And how do we build it for the customers and our clients, right? So we have to care about software, right? To care about the software, we have to care about the hardware running on. Then the infrastructure, then the network. So what we did was, okay, instead of going through the entire stack, right, why don't we partner with Microsoft and look at the capabilities that we require from our business, right? From CapEx to OpEx, from going to creating a disaster recovery, extending our network to the cloud, or creating labs for DevOps or POCs in instant matters, right? And also, we wanted our clients to access our applications and data from anywhere globally while enforcing the security and roles that we require. Then we looked at the entire Azure stack too, right? Because not only the user experience from accessing it from any device, anywhere, and any platforms, we wanted to have software, hardware infrastructure, like AD, security, multi-factor authentication, to extending the network. Then we mapped all the capabilities that we require with Microsoft services, from software as a service point of view, from the platform as a service, as well as the infrastructure as a service. Then we went into our implementation, but we have, just like any other big enterprise corporation, we have multiple locations. We picked our 2 primary and other primary locations that we use, hot, and also we wanted to have the access redundancy. So we looked at our networks. Okay, we have WAN connecting to both sites. We have internet access from both sides, and we had client remote access into the both sites from any location. The first thing we did was listen to what Microsoft was saying in earlier slides. We built our ExpressRoute circuits. Then we started studying our networks. What does our routing look like? How can we route, and what services through what circuits? How do we build not only redundant circuits, but the resilient services into the Microsoft? So the routing part was challenging at first. Much easier going from the infrastructure to platform to the software as a service. Then the first level, we implemented infrastructure as a service. We got our user buy-in. We tested out the circuit, burned in time. We can extend our services, build virtual machines easily. And the routing was tested and blessed, ready to go. The second one was the platform as a service. Now we are getting into more challenges within the routing infrastructure because we started adding into redistribution of our BGP into our internal dynamic routing platforms. And also we had firewalls all over the place, a lot of static routing. How do we converge static routing into the BGP and then the other BGP into the Microsoft? So that was a lot of challenge, right? And now we are researching into policy-based routing. And luckily, as we get into those challenges, Microsoft comes up with a solution that we can use, like the community values, tags that we can automatically inject into route distribution, that we don't have to worry about the destination routes. And the third one is the software as a service, which is Office 365. Now, the biggest challenge we have with Office 365 is the Microsoft's recommendation as, hey, why don't you guys implement it per service base? If we want to access to Exchange, just implement Exchange, right? But we took that one step further. What we are trying to do is only use the sensitive data into our data centers and labs from Office 365, but then separate the user network and let them go through the internet so that we can get rid of the asymmetric routing from the user point of view, because they'll always follow the same path. And also from the server backend connectivity too, if we have any sensitive data or the hybrid environment where we keep the databases and the main like AD servers on-prem, then we have the front-end servers like the web apps and whatnot, right, in Microsoft, either in public or Office 365. Or the same with the CRM services, right? Your CRM front-end is in Microsoft, and all the back-end data that we require to inject into CRM, it's on our on-prem services. So it became much easier for us. Then we have resilience into multi-regional location redundancy. We go into East and Central, and also we connected East and Central together too. If one side is down, it'll follow the other side. And if the East is down, it'll go through Central. If Central is down, we'll go through East. They all back each other up. And each circuit has multiple links too, so they're primary and secondary also. So we have a physical redundancy, we have site redundancy, and we also have the routing redundancy as well. That's all I have. And then at the end, we have all the services, user experience from internet or local. Thank you.
Thank you, Salim. I think that was a great representation of how you could piece together different technologies and build an end-to-end solution for SaaS, PaaS, and IaaS. The next customer we have on stage is Bobby Outlaw from GE. I think GE needs no introductions, so I'll hand it off to Bobby.
Thank you, Ganesh. Good afternoon. I'm Bobby Outlaw. Despite what my shirt says, I work for General Electric, principal technologist, ultimately responsible for our connectivity to the cloud from inside of GE to the cloud. So who is GE? We're a large organization, pretty old organization, 180 countries, over 300,000 users, 4,000 sites. And the interesting thing that I don't think is common knowledge is that General Electric, we are different business units. We're ultimately 10 different entities. So I work for GE Digital, which is effectively a service provider for the other businesses, so we provide common IT services. So ultimately, we're responsible for network connectivity as a common services for all these other businesses which have different requirements, different application stacks, different users, completely different. And so what I'm going to talk about is some of our strategy and how we incorporated ExpressRo to meet our network requirements for different businesses in terms of segmentation, and how we did it across 5 strategic hubs. So I'm a network guy. I got a lot of network pictures. I think it helps paint the story a bit. This is just a very simplistic overview of our edge network and how we connect to cloud providers, particularly in this case with Microsoft. We're spread across 3 different regions, and different sites are categorized in different regions. So we're talking about Americas and Europe and Asia specific. And just to give you guys an overview of how we connect from a remote site through our local WAN to Microsoft's edge. And the interesting thing on this particular slide, that one of the things that we talked about and Ganesh and Charlie covered, was that we wanted to ensure that our client traffic stayed within its geopolitical region, not traverse our backbone if we didn't have to, and not traverse Microsoft's backbone if we could prevent it. So we could get into more of the design and how we achieve that. One of our core foundations is for a network strategy is segmentation. So we talked about 10 different business units. We have a strategy where we isolate down to a routing level each business unit from each other. So effectively, the net effect is GE Healthcare, for instance, a user in GE Healthcare can only see GE Healthcare apps. They can only see, if they logged into a router, they only see healthcare routes in their network, even though this is over common infrastructure. But that presents a different challenge when you segment each business unit from each other, and each business unit has its own app stack. What about common services, like Exchange? So we create points of convergence in our network to accommodate common services across all business units, as opposed to replicating those services 10 times. So one of the challenges with when we worked with Microsoft team was ensuring that we maintain our segmentation strategy. That was critical for us. So in our design, we have dedicated VNets per business unit. Our Office 365 configuration is a shared application, a shared service. And obviously, that's very complex. So wherever else we want to keep it as simple as much as we possibly can. Going back to this topology, we're just kind of zooming in on a very particular section in the coming slides of talking points of really our cloud edge and communicating with Microsoft's edge over ExpressRo. So an overview of our ExpressRo configuration at a very high level, right? So we have basically, at a minimum, we're expecting approximately 60 virtual circuits within our ExpressRo around the world. Now, the math behind that is effectively 10 business units isolated from one another, so 1 virtual circuit per business unit, so that's times 10. 1 virtual circuit for Microsoft services, 1 virtual circuit for Azure public services. So you multiply that by 5, that's how we come up with 60 at a bare minimum. The public services asterisk is there because that is coming online. That's not in production just yet. That's coming online within a month or so. So getting into the specifics of how we connect to Office 365. So as Ganesh and Charlie talked about, BGP is pretty critical, right, to ensuring dynamic connectivity. So we have BGP route peering. In our design per each hub, we have effectively 2 express routes, path A, path B, 2 cross connects, and we ensure that each one of those are resilient. The route design for Office 365, in this case is specifically Exchange Online, is much different than what we do for Azure Private, and you'll see why. But effectively, our path A and B for each hub is active-active, and we handle any type of failover between path A and path B using, at layer 7, basically as DNS. So what this picture is really representing, if you have a user at an enterprise level and they're connecting to Exchange, that we're using DNS to load balance, right, between a proxy endpoint that has a very distinct endpoint that's pinned to path A or path B. And from that proxy, we're NATing that endpoint to a user to a very specific IP block. And that user, so for instance, if you connect to path A, you're effectively a pin to path A. There's no way you can get to path B. So we NAT them to a very specific block that only belongs on path A, or a specific block that only belongs to path B. We had, talking with the Microsoft team, I remember there was a requirement that in an ExpressRo, we have to advertise the same subnets to ExpressRo, right, to the Microsoft endpoint. So how we accomplish that, we advertise both subnets at the same time, but we use BGP metrics to prefer one side over the other just to ensure that we don't black hole traffic. So we're meeting the requirement of advertising this identical subnets on both sides, is just different subnets are preferred in order to ensure the traffic is symmetric. Is very critical, as the Microsoft team pointed out. Our NAT policy, we're pretty conservative with our NAT, so we have a policy that basically restricts 1,000 clients to a single IP. And so when we get to 1,001, it rolls to the next IP in our NAT configuration. And so our NAT pool for each one of our hubs is sized specifically based on that policy. So we took the size of the number of users for that particular region divided by 1,000. And that was the size of the subnet. Because this is premium IP space, right, public IP space, we want to use that pretty conservatively. So Azure Private is BGP, but as you can see, it's a little bit more simple, right? We still have path A and path B. Route design differs, as I talked about before, but it's active-passive. It's very simple configuration in terms of traditional BGP. We use AS prepending for inbound routing and local preference for outbound. Basically, we're pinning all traffic to one side. In case there's a failure, then it fails over. And it's RFC 1918 IP space in our cloud. Now, what we do interesting with Azure Private is because we are segmented across multiple 10 business units, we repeat this process, right? We stamp it out, and we create that technically it's up to N number of times, right? In some cases, what we've seen with our cloud configuration, the VPC or VNet to BU ratio could be many to one. So it's not necessarily a one-for-one, potentially. So you could have a business unit that has multiple VNets, and we leverage that segmentation with different virtual circuits dedicated to those business units to accommodate that type of growth. And this is a repeatable process that we have. The engineers on the team, they thought it would be good to add a couple slides here just to give you guys some screenshots from our portal. And really, what we're showing is just a quick overview from the Azure portal of all our virtual circuits that are in place. And these virtual circuits are Azure Public, Microsoft Peering, and Private. The interesting thing, so if you look at this one here, this is our Office 365 Peering. if you notice in the bottom right corner where the peering says disabled for Azure Public, disabled for Azure Private, but Microsoft peering is enabled, right? And that's how we activate and ensure that this particular virtual circuit is enabled just for the Microsoft peering. And the bandwidth at that particular time when we took the snapshot was, I think we were testing, it was at a gig. Compare that to our Azure VNet private peering, you notice the bandwidth is different, right? So we can size it accordingly to meet our needs for throughput. And also, if you look at the peering, from a peering standpoint, that the Azure private is enabled, but the other two are disabled. And that's just giving a snapshot there of what it looks like in a portal. Our deployment milestones. Initially, when we started, this was a proof of concept. We did everything over open internet. Dev, we just kicked the tires on everything and tested it out. Eventually, in our first hub, we brought up an ExpressRo, and we migrated mailbox access to that particular hub. Then eventually, we rolled Azure Private into that ExpressRo, and then we brought up a second hub. This was interesting because it was very critical to us for these two particular hubs that we have a failover for specifically mission critical services like Exchange Online. So we did not want email to be pinned to one particular hub if there was a failure within that region or that side of the region that we lost email for everyone. So we had to really ensure that failover for email worked seamlessly, and that's why we opted, back to my earlier point, that we use DNS for a failure between all of our locations for Exchange Online. And then after that point, it was just a rinse and repeat, really. We took that, we sort of got the kinks worked out with hubs 1 and 2, and we just replicated it. And eventually, we migrated our MRS and hybrid traffic. That was still over the open internet during this time. We put that on ExpressRo as well. I mentioned Azure Public Peering is coming up pretty soon, and other piece that we're looking at is orchestration of automation of our network provisioning for our ExpressRo. So in summary, right, that the ExpressRo, it gave us a private secure transport between GE and Microsoft, right? That's the primary reason why you want to use it. The dynamic routing is critical for us. The BGP community, we use BGP communities very early on. BGP metrics and the community tagging was very critical for us. We have the flexibility with our virtual circuit speeds for business unit A versus business unit B. And overall, right, using the ExpressRo allow for extension of our segmentation strategy, right, into the cloud. And that's it.
Thank you, Bobby. That was really good. I think it's a good example of how you can have multiple routing domains that can all be put together through a single logical connection into Microsoft. Now, it's my pleasure to introduce you to Leslie from Textron. Textron was one of our very early adopters of ExpressRo, and the least to say, Leslie's team pushed me to the limit and pushed our technologies to the limit and got us on the right track when we got started. Thank you, Leslie.
All right, thank you, Ganesh. Yeah, so my name is Leslie Rowland. I'm the chief architect for Textron. For those of you, let's see if I can, which way does it go? Of course, I broke it. I pushed.
No problem. So this way.
Okay. All right. Yeah. So those of you who don't know Textron, you might know some of our brands that are up there. We're a $13 billion company. We have 35,000 employees around the globe, and we're in 44 countries around the globe. Some of our brands that we're probably most known for is Bell Helicopters, Cessna Aircraft, E-Z-GO golf carts, and a number of other companies here. The interesting thing about Textron is, we are both a aerospace and defense manufacturer and an industrial manufacturer. So we have to deal with regulations, from a government DoD perspective, as well as those businesses that don't. And so we have to have a model that kind of works for both of us. So as we were moving forward with our Azure strategy, we had a couple primary goals. And 3 years ago, we decided that our infrastructure has been outsourced for a number of years, and while we're quite happy with our outsourcer, we weren't exactly happy about being captive in their data centers. So we wanted to get out of their data centers into either our colo or into a cloud provider. So we had a strategy that says, hey, we want to reduce the resilience on that. We also wanted to provide some additional choices and velocity of choices as we move forward with compute and storage capabilities. The other piece, and I think the others have talked about this as well, as the customer demands are increasing. They want things faster, they want it better, they want the newer technologies, and we saw going to Azure as a way to help with that. And then, quite frankly, we also see kind of moving to the cloud as helping with our security posture. Being around the globe and trying to manage multiple data centers and multiple sites creates its own set of complexities for a company. And moving things to the cloud where things are more tightly controlled, we think is a better security posture for us. And the other thing on here, as I said, is one of our goals is we wanted, as we move to Azure, move to the cloud, we wanted that site to look just like any other site in our network. We didn't want our users to see a difference. We didn't want them to feel any difference with that. So some of the use cases that we actually use Azure for is, like I said, first and foremost, it's a primary data center for us now. We have a couple data centers around the globe that we said, hey, we want to take everything that's in that environment and eventually get it moved to Azure, moved it up to Azure. And we are about, I think, out of our server load, we're probably 30% there now. So we still have a little bit more to go, but we'll get there. We also use Azure as a DR site for us. So some of our on-prem infrastructure, as opposed to moving to a traditional colo or DR facility, we are now using the Azure Site Recovery and those services to help support that. We're starting to host applications from a DMZ perspective out there, so moving our DMZ from out of our internet POP up to Azure as well, and using web application proxy and tools for that. We also have about a petabyte of storage, cloud storage. So we leverage the Store Simple appliances quite heavily for a lot of our unstructured data, and a lot of that traffic flows over the MPLS network as well. And then it's also been it was a collateral benefit, but in our acquisition strategy, using Azure for that and Office 365 has really helped with our acquisition strategy. So this is a model here of what our primary deployment architecture looks like. Earlier, Ganesh talked about the 3 different ways that you could connect to MPLS, and as he said, we're kind of that third option. So we are an MPLS customer with AT&T. So we use their NetBond services, which allows us basically to go create a virtual network cloud or connection. And then we can spin up a ExpressRoute connection and then go peer that in any location where AT&T has a peering location at. So once we do that, we basically pick multiple data centers within that region to basically take that ExpressRoute connection and share across there. So we are able to create applications and have a primary and secondary data center that they can fail over to if the application needs that requirement. And we also share that same ExpressRoute connection across those. So we get some efficiencies from that way. We also enable public and private peering for most of these, or at least for the non-government related ones. And we then take that model and then kind of basically stamp it in anywhere we need it. So currently right now we have 3 primary locations we peer in. For EMEA, we are peered to Amsterdam, so we take that same model we had and we go to 2 data centers in Europe. We do the same thing in North America. That comes out of Washington, D.C. And then kind of the unique thing for us is the government cloud that you see there that we use for all of our DoD businesses. That's just probably not even 6 months old yet, so we don't have a tremendous amount of data out there yet. But this is kind of the one where you said there was that private network that's for federal customers that's completely separate and distinct, from the public side. So that meets our requirements for our DoD businesses. So as Ganesh said, we were one of the earlier customers with ExpressRoute. And when we first started with our Azure journey, we started down the path with VPN and quickly realized that that wasn't going to support us from a production perspective. It was okay for dev and test, okay for those use cases, but from a production workflow perspective, it just didn't meet our expectations. It really hampered our adoption, and it wasn't until we really moved to ExpressRoute and got on part of that pilot that we were able to really start to get velocity from our customer base. And as he also said, is Textron had a very large network at the time, and our number of routes that we had was something that they could not really help us with at that point in time, or actually it was over their route limit. So that caused some issues, but they were, I would say, worked very diligently to help meet our needs and engineer a solution to make us so that would work for us. And then that actually, I guess, turned into ExpressRoute Premium, if I understand correctly. So where we are today, like I said, is, we are basically, looking at with what we can do with the AT&T NetBond ExpressRoute as kind of an extension of our SDN capabilities. We're in 3 geographic regions, and we're in 10 data centers really within the last 2 years. We're taking a strategy where we're starting to decentralize, so where we had large concentrations within a single data center, we're using Azure and the capabilities there to really decentralize where that workload is. So we want to get it closer to the business and where it's being executed so it can increase their performance. And we're also looking to, if you would, not put all of our eggs in one basket. So if there's an issue or an outage or something that's in one region, that it doesn't affect all of our business segments. And so that's something that before we just didn't have the capabilities to do. And so it's something that's been well received. Kind of what's helped our adoption, like I said, the first biggest thing was ExpressRoute, just from its performance. So far, knock on wood, we've really had no downtime that we've been able to detect. And I think Ganesh, you said earlier today that we've had, 7 updates in the last year, and they've been seamless to us. We've never seen it. The NetBond services we use within NetBond, there's 2 things in there. Excuse me. The route management toolkit that we leverage to inject routes and help us, if we need to use the default route or specify specific routes, we can do that within there. But it also allows us to provide firewall services at where basically the pairing location. So that's where we provide all of our firewall rules for this. The other big thing that we've started to play with a little bit is the network security groups and user-defined routing. So we're starting to, in certain cases, for some of our industrial-based businesses, have servers that can actually hit the internet and at the same time still be able to enforce routing for the other pieces. So I guess in summary, I'll just say that for us, ExpressRoute has been probably the biggest factor that's helped with our adoption. We can go provision the circuit, deploy something probably in less than 30 minutes now for a new data center if that's what we needed to go do. So I guess we'll turn it over to Bala then.
Okay, I'm Bala. Before I go further, I want to take time to actually thank our customers, Salim, Bobby, and Leslie, for taking their time to come here and share their experience, and also giving us the feedback and making our product even more better, right? Thank you one more time. Okay, so I'm Bala. I'm a program manager from the CAT team. I work on hybrid connectivity scenarios. Basically, what I do is from CAT team, basically we work with customers to help them architect their network connectivity design, especially work with Bobby in this case. So to design their network and also any new technology that they adopt, and if they have any blockers, we help them unblock, or if they provide us feedback, I come and feedback to Ganesh and Charlie to make the product even more better, right? So thank you. So I've been working with ExpressRo for quite some time, and late spring, early summer, we had a lot of customers using ExpressRo and connecting to Office 365, and had some challenges in deploying and connecting to Office 365. And so I thought I'll share that experience, and then as a result, we have provided an updated guidance on how to connect to Office 365, and that's what I wanted to share here. Basically, one thing I want to make it very clear is ExpressRo, to connect to Azure, ExpressRo is really recommended for all large enterprises. And SaaS offerings like Office 365 are generally designed to work to connect over the internet. You can also connect to ExpressRo, but you have to plan really. And so because they are designed to work over the internet, when you want to connect to Office 365, we recommend it for specific scenarios, right? So especially some cases where you are a government or financial sector customer, and you want to really have a private path and not go over internet in those cases. And also, if you have Skype for Business and you want to have quality of service for your media calls, so where ExpressRo can provide the dedicated bandwidth for those calls, in those scenarios also, ExpressRo is recommended for Office 365. So what does it really mean about this new guidance? So if you are already an ExpressRo customer and connected to Office 365 using ExpressRo, there is no change for you. You can continue to use it, and we will fully support you. And if you are a new customer, what we want to make sure is you really plan very well for it, and making sure that you will really benefit by connecting through ExpressRo. We want to make sure that you assess that, and our account team can help you engage our partners or our Microsoft Consulting Service or field services to help you assess your network and make sure that you will really benefit by using ExpressRo to connect to Office 365. So that's an important thing. So when that is, when we decide that, yes, you will benefit from ExpressRo, then they can provision you to connect to Office 365 over ExpressRo. And there are additional technical guidances available in this link that I shared here. So why do we talk about this additional network assessment and things like that? I just want to step back and give you how the connectivity generally looks like. So Office 365 is part of a large Microsoft network, and you have your corporate network. You can connect to Office 365 over the internet. And in a typical case, the user could be from the internet directly accessing Office 365, or the user could be in your on-prem connecting over the ExpressRo or connecting over the internet to Office 365. And also, there are certain things that you need to consider. So, for example, you may still need to reach out to some CDN resources that are part of Office 365, and you should be able to resolve those names from your enterprise. And also, since these are connected through a secure connection, so you want to make sure that you are able to access the certificate revocation list and update, and making sure that you are really connecting securely. And Office, the ExpressRo also provides an alternate path based on like what destination you really want to access, right? So we talked about various scenarios, like only servers will connect, or clients also will connect. So depending on the configuration choices you have, you will have connectivity over ExpressRo, or sometimes in some resources you will be accessing over the internet. So and in each case, you will have firewalls in front of it. So as Charlie said, you want to make sure that you have the route symmetry, whatever traffic going over internet comes back via internet, whatever going over ExpressRo comes back over ExpressRo. So we want to make sure that you plan for those route symmetry things. And because Office 365 has various services, and some of the services are available over ExpressRo, some of the services are available only over the internet. And this link gives you the list of services that are how you can reach those services, right? And in order for you to plan, like I said, first thing is you should still plan for your internet connectivity in terms of how are you going to access the static content and what advertisements you are sending over the internet, and especially your firewall and proxy configurations. Because Office 365 is like a trusted endpoint, do you want to do a deep inspection of all traffic going over your proxy servers, right? So you may want to exempt your proxy, your Office 365 destination from going through layer 7 inspection, right? And then if you are going through ExpressRo configuration, you want to make sure that how are you advertising your prefixes to Microsoft and what prefixes are advertised into your network from the Microsoft side. You want to make sure you understand that. You want to make sure that where all you are propagating your routes internally. And sometimes what may happen is because Office 365 is kind of a large network designed to work over internet, we keep adding additional services, additional resources. So the number of routes, the IP addresses of those resources will keep changing. And so we will keep updating those routes. And sometimes what may happen is customers will try to put some static filters in their firewall and allow only those destinations. In those cases, then when we change our IP addresses, you will have some trouble if you maintain static routes, static prefix filters. So that's why we would like to guide you to avoid those kind of prefixes. And then quality of service. If you are using ExpressRo and you want to use it for Skype for Business and especially control your media traffic for Skype, you can do that with the DSCP bit that you set and making sure that that DSCP bit is honored within all your WAN infrastructure. And when it comes to through ExpressRo, we will preserve those DSCP bits so that you have the desired bandwidth dedicated for those media calls. And then the hybrid portion of it, like what is that you are going to advertise from your network to Microsoft so that the Microsoft servers can reach out to your thing and ensuring path symmetry. That's an important thing here. So that's what we commonly see. Customers are not able to understand this part. So that's why I want to stress on this part again and making sure that you ensure route symmetry. Because you have two paths going over internet and going over ExpressRo, you want to make sure that your firewall see traffic on both directions. Okay, some more useful links. In summary, I just want to conclude basically like what all the things that we say, like ExpressRo is truly global service and it is expanding, and our partner ecosystem is also expanding. And we are providing additional features like high availability and also high performance with the new gateway performance. And we are also working on, we have also given you the additional telemetry and troubleshooting tools. And like Charlie talked about, when we add more features and when it becomes complex, we just wanted to make sure that you understand how the route symmetry works and how can you ensure high availability using this AS paths. And finally, follow the guidance to connect to Office 365 over ExpressRo. There are additional links. And that's all I wanted to say, but I want to take a moment and say there are a lot more networking sessions tomorrow on networking Azure networking features. So some more sessions here. And because I come from the CAT team, Customer Architecture team, our team has additional focus areas. I belong to the hybrid scenario thing, so I work with a lot of customers like Bobby. You can also reach us. We are available worldwide. And you can also come to our booth. And these are the ways you can get to us, so we can help in terms of your architecture design, or if you are really blocked on any deployment, we can help you unblock from those deployments. And then if you have feedback, yes, definitely, we'll take those feedback and feed it back to the engineering team. Okay. Thank you.